Hi. So, welcome to our lesson about triangle congruence. Today we're going to be talking about the side, side, side and angle, side, angle postulate of congruence. And we're also going to mention the angle, angle, angle postulate of similarity. So remember we had similar figures, and that's when the lengths of their sides were in the same ratio. And now we're going to prove triangles, either similar or congruent, based on measures of angles or lengths of sides. So let's look at the side, side, side postulate first. That's going to be the first one on our list. Two triangles are congruent. Remember that means equal or the same, even identical, if this is a conditional statement. Two sides are congruent, two triangles are congruent if all three sides, corresponding sides, we need to make sure we start learning that. Remember we had corresponding angles when we had the two parallel lines and the transversal, and they're basically in the same location with respect to one another. Well, we also have corresponding sides of triangles. And we probably should say if the length of all three corresponding sides are congruent. And that is your side, side, side postulate. What it looks like in a picture, and keep in mind, we're not just dealing with right triangles here. This could be any kind of a triangle. So we have the black triangle, and then let's make the red triangle. And geometry test makers love to flip these shapes around, rotate them, reflect them, and transform them, just to try to hopefully confuse you and keep you from knowing which side matches with which. So if we're given some marking, this side and this side, that means those are congruent. And then let's look at the longer side of that. Let's say those are marked as being congruent by 2 hash marks. And then maybe on the other side, we're given this symbol says, hey, those are congruent. Now, if we label this triangle with some vertex names, triangle A, B, C, and triangle D, E, F. The first thing that we need to look at is naming triangles in the proper order with correct sides. So the order in which you name a triangle when you're saying they are congruent will affect things later when we start discussing similarity. Ask yourself, what is the corresponding side to side AB? Well, in this one, it's FE. The sides that match up might be another good way to say that. So our congruency statement says triangle ABC is congruent to triangle FED. You want to name your triangles in the right order so that corresponding angles and sides are named in the same order. So you notice side AB corresponds to side FE, so we name them in the proper order when we name the triangle. That's important. It's not as important in this lesson, but it will be important later. And those triangles are equal. They are equal because all three corresponding sides are congruent, because we have the marking. Now, if we had two different triangles, whoops, I knew I was accidentally do that. So let's have a green triangle. And let's have a red triangle. Some questions you're going to get are going to be worded like this. Move this up here for just a second. If you were going to use the side, side, side postulate to prove these triangles congruent, what information is missing? So they're not necessarily always going to have you look at a picture and say, yep, they're congruent by the side, side, side. They're going to have you analyze these, and they're telling you, hey, if you were going to use the side, side postulate, what information would you need? And they might give you something like this. They might say, this is congruent to this. And they might say, this is congruent to this. And then you might have this. Clearly, you are missing a piece of information. What are you missing? If they are going to be congruent using side, 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 what piece of information do you need? And what you need to know is segment AC is congruent to segment FH. That is the piece of information that you're missing, is that this side of the triangle is congruent to the other side. We do not have this marking. We do not know that these are congruent because there's no marking showing that in the picture. But if we were going to use the side, 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 that is exactly what we would need. Not saying we're going to get it, not saying they are, but they're going to ask you what piece of information is missing. Now, while we're looking at the side, side, side postulate, let's talk just a little bit in advance about your angle, angle, angle similarity. We could have the exact same angle in two triangles, but those triangles might not necessarily be identical. An identical triangle has sides and angles and everything all the same. It's the same size. You put one, lay one on top of the other. It's an exact replica. Be careful in a situation like this. Let me see if I can draw two triangles that are equilateral triangles. Is what I'm attempting here. Now remember, an equilateral triangle, all three angles are the same. and all three sides are the same length. So there are two equilateral triangles and equiangular. One implies the other. So all angles in both of these are 60 degrees because they're equilateral, equiangular. Every single one of these angles is exactly 60 degrees. So they're all equal in both triangles. That's your angle, angle, angle in action. But are these triangles congruent? Are these triangles equal? Does that equal that? If we were to put those, lay one on top of the other, would they be exact replicas? No, absolutely not. One is tiny and one is big. These are not congruent. However, they are similar. The sides are definitely in proportion to one another. So possibly you could have all three angles and have two congruent triangles, but it doesn't necessarily mean that the triangles are equal just because all three angles. You do know for sure that if all three angles in two triangles are congruent to one another, then the triangles are similar. Now, it doesn't have to be an equilateral triangle. We could be talking about right triangles maybe, or even a triangle like this, an obtuse triangle. We could have an obtuse triangle that has the exact same angles as a larger obtuse triangle, but those are not identical. And obviously, all three angles inside are not identical to each other. So what I mean is, are all three of these angles the exact same? No. But if we look at this in relationship to the smaller triangle, those angles are congruent to one another. But the triangles are not equal. These two triangles are clearly not equal. They are similar. The side lengths are proportional, and we will study this a little bit more later. I just don't want you to think that if a triangle has the same angle measurements as another triangle, that means they're automatically congruent triangles. They are not. They could be, but they're not necessarily. They are definitely similar. All right, so it's important the order in which you name a triangle. This is important. The congruency statement is what that is. When you're given a congruency statement, from that statement, I already know three things. No, more than three things. I know that angle A is congruent to angle F. I know angle B is congruent to angle E. And I know angle C is congruent to angle D. Because of the congruency statement given, because they put those vertices in that order. I know that segment AB or side AB is the same exact length as side FE. I also know that side BC is the exact same length as side ED because of the order in which the vertices were listed in what we call the congruency statement. And that's what that is in the box. Triangle ABC is congruent to triangle FED. And usually there will be in front of that a little triangle shape like so in that statement. It will be right in front of that to let you know they're talking about a triangle. They'll put an image of a little triangle in front of it. Okay? All right, now let's look at the ASA postulate. Good time to pause the video if you didn't get all that in your notes. Because now I'm specifically only dealing with ASA. And what ASA means is angle, side, angle. And they have to be in the same order. So angle, side, angle gets a little confusing because you have to read the triangle in the same starting place and go in the same order. So let me tell you what I mean here. If I have this triangle, and let's say I know this information here, 15, 15, and maybe this is 50. 50 is my angle degree measure there. 15 is the side. Now, if I read this triangle and I start right here with the 15, I know a side, then an angle, and then a side. Side, angle, side. Now, if I have that, all I have is a side, side. If they've given me this measure, what I have is side, side, side. And let's say I'm given those measurements. Now let's start and read the triangle. So I'm given an angle. Then the next thing going around the triangle is the measure of a side, then an angle. This is angle, side, angle. Angle, side, angle. Now sometimes these triangles in these pictures aren't going to be separated, but maybe these triangles are sharing some sides. For example, let's look at number 2 on your worksheet. Number 2 looks something like that. And you have 2 triangles in number 2. They're just touching. They have a shared side. So we have vertex Y, X, Z, and G. Now, if you took those triangles apart, they would both have YZ. So this is a congruent side already because it's the exact same side. If you remember, we did some properties. We talked about them a few lessons back. YZ equals YZ, and that is like you're looking in the mirror, so that's the reflexive, like a reflection property of equality. And you might have to state this in a proof if you're trying to prove two triangles congruent, which is where we're headed with this. That's the reflexive property of equality. I know YZ equals YZ, so I've got my first side. So I have a side and an angle. So let's read the triangle because the question says, if you are going to use, that's not exactly what it says what additional information, is required in order to know that the triangle using the angle side angle postulate of congruency. I want to use angle side angle. What more information is required? Well, let's read triangle XYZ. So I have a side, and then if I went around the triangle, I'd have the angle. Well, then I need this side right here. I need to know something about side XY, right? Well, let's read the other triangle. I have this side, then I come out, and I have this angle, so I need this side. If I'm going to use angle side angle, I need to know that side XY is congruent to I'm so sorry. That was side angle side. I hope you guys noticed that I was reading that triangle completely wrong. I am so sorry. Back up. If I read what I have here, I have side angle. What am I missing? Let's go from the other direction. Let's start with the angle. So angle, side, angle. I need this angle right here, don't I? I need that angle. Now, if I'm going to use the other triangle as well in this congruency statement, let's start at the angle. So I go out to the side, around to the angle. Angle, side, angle. Now, if I take those two triangles apart, it might be a little more clear. So I'm going to have triangle YZG, and I'm also going to have triangle XYZ. So, whoops, take those right apart, just like so. What I know about them right now is this side and this side are equal. And I've been given in the picture that this angle and this angle are equal. All I did was I cut this in half. And I took it apart to give me this one and this one. Now let's read them when they're not stuck together because sometimes that's easier. So I'm looking for angle, side, angle. Let's start at the angle. To the side I know about. What am I missing? The angle. Start at the angle I know. To the side, what am I missing? That last angle in the story. I need to know, in order to use angle side angle, that angle XZY is congruent to angle GZY. If I knew that one piece of information, I could say absolutely those are congruent based on the angle side angle postulate. That is the one thing I'm missing. Now, it's important to know that we might also name angle XZY. It could also be named angle YZX because you don't have to name the angle in any proper order. And it also could be named YZG. So for an angle, that middle letter showing the vertex is the important part. It's the same angle no matter what. Angle XZY and angle YZX are the same exact angle, it's the black angle. The other one, angle GZY or angle YZG, that's the red angle. The hard part is reading the triangle. So if it's angle side angle, start on an angle, go to the very next side. Now where do you end up? At the next angle. Or start on an angle, go to the side, where do you end up? At the very next angle. You could even put this in a matching color so it'll match our picture, because that is actually the other one. Okay? All right, this worksheet is all about using angle side angle and side 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 postulate. There's nothing about the similarity between triangles with the angle, angle, angle on your worksheet. I just did not want you to start thinking, hey, well, if all the sides are equal, so are the angles. That's going to come up later in similarity. So kind of keep that out of this one. All right. Good luck, and I'll talk to you in the next lesson.